Assalamu alaikum, and today I will be again continuing with the course, and I am on this part right here. This is the linear independence. Essentially, this uses the Gaussian elimination method. I'm trying so hard to understand it. I get the gist of it, and I'm going to code it right now. Actually, I should open it right here. Um, CD projects, AI from scratch, and engineering. Phases and code here. So this was the part ML fundamentals. So matrix, I was doing this part essentially. I've done the transpose. I need to do this linear independence algorithm. I don't fully understand it yet. So I will create another file called uh, linear independence. All right, and let's do this. So I have to define is linearly independent. Vectors. So for a matrix to be linearly independent, its rank should be equal to the number of rows. So first I need to get the number of rows. That is simple enough, I guess. It's just the length of vectors, meaning this is a vector array, right? So I need to also import vector. This is an array of vectors. I think this is how you define it in Python. I don't know. How do you define an array of vector? Actually, I shouldn't be worrying about this right now. So this is n. Now I need the matrix. Matrix is equal to matrix from the I am going to copy all of the vectors. So this gives me the entire copy. It gives me a shallow copy. So import matrix. This gives me a shallow copy for V in vectors. Uh, I think this is how it is. So V, is this correct? Or this going to give me an error? Can I even access it like this? So no, I don't think I can access it like this. Let's see. V dot components, yeah. V dot components. Basically, I'm making a copy of the components. V dot components, and this I'm essentially creating a matrix. I'm essentially creating a copy, and that's it. Now I need to know the dimensions. Dimension is dimension of the vectors. Is it a 2D? Is it a 3D vector? So for that, I just need to do vectors 0 dot components, length of the vectors. That's it. The first vector or the second, it doesn't really matter. Now I know the matrix. I need to know the number of rows, I suppose. The number of rows isn't it just the dimension of the matrix? Now what else do I need? I need to go through each column and eliminate the bottom rows so they become all zero. And the next column and find the next number and make the top and bottom zero of that. Okay. Um, Matrix calculator. I guess I'll just create a matrix for, it should be a 3 by 3. 4, 3, 2, 1, 2, 9, 23, 77, 88. I don't know. That's good enough. So essentially what I need to do is I need to find this. I need to find the in the first column, I need to do is make these zeros. So what I'm going to do is I'm going to first select a pivot to swap with, essentially. So if this is greater than 0, like in the algorithm, then I need to eliminate this. So I will divide the entire column by 4. So this becomes 1, this becomes 3 by 4, this becomes 2 by 4, or 1 by 2. And after this is done, I need to go to this. I need to make all of these zeros. And for all of these, I will divide. I need to subtract from it 1, subtract from it 2, and subtract from it 3. Actually, all I need to essentially do is subtract from this um, 4. No, I need to multiply this by 4 and subtract this top value. So this entire thing, this becomes 0. Then I need to make this 0 as well. I think I get the gist of it, but explain it is easy, but doing the actual code is hard. Now I need the number of rows. Number of rows is equal to the row. Where does the row come from? Row for row in the mat dot rows. Matrix dot rows. So I'm essentially getting making copy of all the rows, and rank is equal to 0. So by default, I'm supposing that the uh, vectors, the matrix has a 0 dimension. Now I need to go through the columns one by one. Call in the range dim. So I go through each of the column. I need to select a pivot. So for row in range, length of row. Um, for I need to make this with rows. For row in rows. If the matrix matrix, how did I retrieve it? It's like, yeah, it's just like this. Okay. Range from rank till the length of rows. Why is that? Why is this different? So for the first case, this will be 0 till the length of the rows. Oh, I see. I see. So if one of them is already 1, then I need to just take care of the other two. I see. So it's from the rank till the length of the rows, and if absolute value of the row and call. I want to do this on my own, but this is a very hard rhythm. I just don't know. IE minus 10. So what this does is basically some of the rows are in are in decimal numbers, are floating point numbers like this, essentially. Now the computer is sometimes imprecise, and it will give a floating point error below something uh, after 10 decimal digits. So essentially, I cannot do this from what I have researched, because some of the matrix will have some amount of value greater than 0, some of the numbers. So I need to do this essentially. And if it's greater, then this is going to be the pivot. Then this is going to be the pivot. Pivot is equal to the rows, row, and column. And I'm going to break this. Is that correct? And I haven't defined the pivot on top because the variables in Python are function scoped. So essentially, this variable inside belongs to this entire function. So then if pivot is none, I essentially continue, meaning I do not find an empty, I do not find an if I find an empty value like 0, if I find a 0 there, I basically skip this iteration, I go to the next row. So below 0 there, let's suppose there's this matrix and there's 0 here, then I don't do anything with this. Instead, I continue to this. So this skips that and goes to the next row. Okay. Then I need to swap the rank with the pivot. Now this was the confusing part. I need to rows rank um, rows rank. I need to swap basically this to pivot is equal to rows pivot rows rank. So I basically have swapped the pivot with the rank number. So basically, if the rank is 1, so basically this is 1, then what I do is I take this entire value, I suppose, rows rank this and pivot, pivot. Pivot is wait a minute. This is not supposed to be a list. I think this is supposed to be just the colon. No, this is supposed to be the row. So I am supposed to swap the entire row. So suppose this is what solved and the rank is 1. This entire thing is solved and the rank is 1. Now I am going to move to this second column. I am going to check if this is a non-zero, then this is the pivot, essentially. Then I am going to swap the rank version, meaning this one, with this one itself, so it doesn't do anything in this case. Then what do I need to do? Scale equals the row rank column. So scale equal to row rank col. So essentially, I'm going to find the um, row. I'm going to find the this. I'm going to find this in this case. Let's say this is 2, this is 3. I am going to find this as a scale. There's 0 and 0 in the first case. So I'm going to find this. I'm going to scale it by a certain factor. So rows rank equals x divided by scale for x in rows rank. So the first one, I am trying to eliminate, I'm trying to make this one. So I am trying to 0 and 0. So this, let's say, is a non-zero. This is 8. So this will divide the entire row by 9. That's what I understand. So it divides the entire row by 9. The first one becomes 1. Then what I need to do is I need to make everything below 0. So for row in range length of rows, for row in range length of rows, I need to go through each row. If the row is not equal to the rank, meaning I skip the not equal is a different word, I think, in Python. This is good. This is good. And abs row call greater than IE minus 10. So I skip the row which is already 1. I skip the element which is already 1, and I need to make all the other elements 0. So the factor is row call. So I am getting the next row. I'm going over here after turning this into 1. And this is 3 by 9, then this to 2 by 9. I'm going to this one. I'm skipping this uh, due to this condition. Then I'm going to make all of these 0. I find the factor of this. The factor of this essentially itself. So for the length of the rows, I find the row. So I find the 0, 0 is the factor for the first one. Hmm. So this is the absolute value is greater than this. And then I do is row equals row j minus factor uh, multiplied by rows rank j for j in range. And for the j, this is confusing. This part is confusing. Row equals row j minus factor rank j, but j in range. So for the j in range, the dimension, is that correct? I was trying to guess it myself. Please be okay. Yes, 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 yes. That's good. So what is this one doing? I'm trying to understand. So I find the factor of this, I divide it by this, so this is already 1, so this is row is going to remain the same. Then I find the factor of this, 2, I divide the of this to be 2. Then what do? I take the row and I may go through each of the column and I subtract the factor, meaning I subtract the factor of this was 2. I subtract from this value, subtract from this value. What do I subtract from it? I subtract from 2 1 multiplied by 2. So this becomes 2. And I subtract from this, and this becomes 0. Then I multiply this by the factor, which was 2. So then this becomes 6, this becomes minus 4, and then I go here, I multiply this by 2, this becomes 4, and I subtract from this, and that's that. So this becomes 0, this becomes 0, this also becomes 0. That is great. So now the algorithm is pretty much okay. Now, when do I increase the rank? If the entire row is 0, then in that case, I need, okay, so this levels the entire thing. I want to figure it out. This makes everything 0. This makes the upper one 0. Now, if an entire row is 0, I do not increment the rank. Otherwise, I increment the rank. So what I need to do is if if I need to go through each of the rows. So should I make another one of those really? There must be an easier way, but this is all I can think of. So increase the rank a if a if a row doesn't no. I need to increase 0 when this is 1, this is 0. But second row, the second one is 1, the both of them are 0. How do I go about doing this? So this is 0, this is 0, this is 0, this is 0, this 0, 0, 1. I need to check if only the diagonal entries are 1. Okay. I need to check if the diagonal entries are 1 and everything else is 0. That's it. So check if all diagonal entries are 1. It's simple as that. So uh, for for diagonal element in range of the dimension, I go through each of the rows. If the row diagonal element, meaning it's all of these are going to be increasing one by one, not equal to 1, meaning it's not 1, then return, then I don't, is equal to 1, then I increase the rank. Rank plus plus. Python doesn't have that, so plus equal 1. So this increases the rank. All right. This increases the rank and return. So this is supposed to return a Boolean. So I could write bool here. Return rank equal to the n, meaning the number of the dimension of the vector. Is this good? Have I done good? They have done it in a different way. So they have done it in a different way. Okay. I need to confirm if my core algorithm is good, if what I have done is good. Now, the only way I could check is by making someone see my algorithm, but I don't have a senior. The only senior I have that I could talk to right now is the AI. So I guess I should confirm it with the AI. So I guess I will use it, but I will only ask it to guide me in the learning process and nothing else. So, gems. Learning couch. Tell me, is my in linear independent function good? Just provide the hint about if something is wrong. Don't give the straight answer. So let's see. Couple of logic bugs. A reset scoping issue. Specific row reduce echelon to find the rank of the matrix. The overall logic into rows clear. However, there are a couple of logical bugs. Here are two hints. The pivot variable resets scoping issue. Look carefully at how pivot is initialized inside your column. If no entry satisfies the value, it skips the column. No, I don't understand what it wants to say. The pivot, look carefully at the pivot is initialized and used inside your for call in range dim loop. What happens in a column if no entry satisfies this property? Okay, so let's say that if no entry in a column, if no entry, so this is 0, 0, 0. So what happens then? So 0, 0, and 0. Then in that case, the pivot is none and it continues. So I go to the next column. Then if it's 0, 0, 0, then I check in and it's 0 and I pass through, then I don't get what's wrong. The rank check, I am trying to do it on the first level. Why is it wrong? Each pass of the column loop works on Volca. You haven't finished the reducing the rest of the matrix yet. Checking diagonal entries. Oh, this is outside. This should not be. Oh, right. Okay, so the problem was the spacing. Spacing was the problem. Okay, this is good. All right. What was wrong with the pivot variable? Uh, for row loop starts, pivot is an add, assign, and like pivot is equal to none. Is all zeros. The will never be true. That means pivot row never runs. When the loop finishes, Python returns none because never created. Python crashes. With an so I need to define it. So, but they didn't pivot equals none. So that's essentially what it's. So I should define it like C. Now, is this good? There are two small logical bugs still. All right, I guess what they are saying is correct. Then I could just do this inside this loop. So rank plus equal 1, meaning if I reach the end, then obviously it's 1. So this is the problem. Declare once outside the column. Okay, so this isn't reset, so this should be here. Is this good now? Is this good now? Yes, great. This is great. Now I will continue later, inshallah. All right, so I will be continuing. So I was right over here. I need to project A onto B. So I need to create another function. Project A onto B, scalar A A dot B divided by B squared. So it's just B dot B, B with itself. Then I return the vector multiplied by the scalar for each of x dot components. Why is that? Why do I do that? I don't get it. Uh, So this is the concept in linear algebra. I know this. So this was the thing. A dot B, B dot B, and this gives me a scalar. So I multiply it by the B vector, the every single one of them. So this gives me the projection. Then I scale B by it. So from what I know, this is going to be smaller. So this is going to shorten B essentially. I could also use this formula. This should work as well. So A dot B hat times B hat. Walaikum salam. So, so the thing I should do is I could use this formula, but this formula is also fine. So I get the scalar and I multiply each of the values with that. Fine. But this is a nicer formula, I think. Could I just write it like this? Return A dot B and B dot normalize, and I multiply that. Well, I will still have, oh, I understand. If this is the case, I need to return vector where each of the multiplied by x for x in B dot components. I understand what they did there. So I would also have to normalize this again. Normalize, and then I get the components. So their method is better. I get the scalar A dot B. Then I simply scale the B by that amount. Return the vector uh, scalar multiplied by x for x and B dot components. Then what I need to do is I need to do the Gram-Schmidt process. Gram-Schmidt process. The Gram-Schmidt process, I need to go through each of the vector for it's going to take in an array of vectors. For a vector in vectors, the norm perpendicular orthogonalized vector is equal to vector. So for so what I'm going to do is first I need to know orthonormal or most. I need already the orthonormalized vectors. Else what I'm going to do is I am going to normalize the vector. No, I need all of the other vectors for vectors in orthonormal. What I need to do is projection is equal to the is equal to the I need to project the orthogonal I spelled that wrong. Orthogonalized, but I need to current current. I need to project the no, I need to project the normal onto the current, and it doesn't really matter. Then what I need to do is I need to subtract. So it's basically like this. First vector, just normalize it. Second vector, then for every other vector, subtract the component. Then for every other vector, the subtract the component of the vector is that is perpendicular to the other. So essentially, current is equal to the current vector. So essentially, um, the current vector, current minus projection on the other vector. So I get the projection on the other vector. So I get the projection, then the current is equal to current minus the projection. The current is a vector. Is this going to work? Am I doing this correctly? Orthonormals, then vector and vectors, the current vector for U. Okay, they have done it differently for normal in orthonormals. Project the current vector onto the normal, then I do current minus the projection. If W the magnitude, if the current dot magnitude is less than I, it's 10. Continue. So simply speaking, if the magnitude of the current vector is 0, meaning it was already perpendicular, meaning it was in the direction it has lost all of its x component, then I just continue orthonormals dot append current dot normalize, and then I return the orthonormals. Okay, this is good enough, I think. Gram-Schmidt. This is good. This is good enough, I think. Then what do I do? So this is good. Now all I need to do is test it out. All right, let's create some vectors. So v1 is equal to vector 1 0 0. Actually, I could just copy paste this since I'm going to write any. Basis is equal to Gram-Schmidt's. I did this, but I did not use it at all anywhere. I don't think so. So Python linear independence. All right, I need the source, bin, and activate. All right. V1, did I do something wrong here? Is this anyone allowed? So do I really need to define it like this every time? I need to define this like this every time. That's annoying. So port vector from vector from vector port vector. This is better. I see the problem. Why is printing that? So this is the problem. I think this is why that is being printed. Is this the reason? Yes, I think it is. So I need to now do the matrix one. So this is the reason for the dunder there. So the other module uh, just doesn't do that, this kind of stuff. So this is the problem. Current minus projection. I cannot do that. I cannot do current minus projection since So there's also a problem in this file as well. Why? Tuple has no modular components. Why is it saying that? It does have. Wait a minute. So print other for once. So what's going to print? So here, it's creating a tuple. I don't want a tuple, so it's going to be an array. How did they do it? I'm pretty sure they did this similar to this, but that's the difference. Zip others dot components. Okay. So it's what is the mistake that I have made? I do not understand. Self dot components and other dot com. There is this. This is a list, so this should work. I don't understand. I'm going to print the other. Tuple object. It's a tuple. Why? Why is it a tuple? Don't understand. I'm not passing in it. Am I passing into the tuple? I don't get what's wrong over here. So I'm passing in a tuple. It's supposed to be vector. List components. I don't understand what's wrong. It's saying that the tuple object has no attribute components. But I am not passing in a tuple. I am passing in a vector. Why is it giving error? I don't understand. But if I just copy the paste this will is still giving error. So there's not a problem with this code. There's a problem with something else. This code is just fine. The problem is here, so what is wrong? Why can't I figure this simple thing out? Current minus the projection. Oh, this is the problem. So this gives me all the basis vectors, and when I make the dot product of them, all of them are zero. Yes, this is working, so I understand. Now it's working. And, guess I should do the Julia version as well. I have the Julia interpreter. I think I have it. So Julia, okay, it's working. So so A is equal to 1.0, 2.0, 3.0. B is equal to 4.0, 5.0, and 6.0. So it doesn't print ln A plus B is equal to A plus B. I should guess I should do this in VS Code as well, because this will make an extra file. Now remember it here. Uh, Julia version.jl. A plus B is equal to A plus B. A dot B dot B. So it's simple as that. It's already built in. It's already built into this. So now to inside this, then the magnitude of A is the square root of A dot A. How do I even write the square root? How to write the square root symbol in Julian? It supports that, but typing slash squared. Single value with this, hit tab. Squared, I guess this is fine. I don't need. The final thing left is the cosine. So this is just A dot B divided by magnitude of A and magnitude of B. So squared A dot A and multiply by squared B dot B. White space not allowed? White space isn't allowed. What? That's weird. Load error again. Type array has no field B. What does that even mean? I don't get what I'm doing wrong. Let's just write this entire thing. What will happen when it given errors to? And let's see. It's still giving a load error. I don't know why. When their version is given an error, why is that? Because I'll ask and I have never used Julia, so I guess this is a good thing to me. Loaded, but they live in the standard linear algebra library, so using linear algebra now, still a load error. So this is the case, and then what else? Will multiply by my jaw hurts. And now the so I should have uh, brackets around this. Now with this one, still a loading error. Let's see this. This is not working. So the problem is how do I write the Unicode characters in VS Code with tab like So to get over what's where the Julia extension. Okay, well this is fine for me. This is good enough for today. And git commit the did did Gaussian um the reduce echelon form and the Gram-Schmidt process. Push. That's it for today. Thank you for watching. Allah Hafiz. I will see you next time, inshallah. Bye bye.